17 from the review packet. Given the rational function x minus 1 divided by x squared minus 3x minus 4, determine the following. What are the intercepts, x and y? What's the vertical asymptote? What's the horizontal or slant asymptote? What's the domain and the range? And finally, to graph the function. Okay, so let's jump right into this. The first thing we're going to do is we're going to write our function here the way it was given, x minus 1 over x squared minus 3x minus 4. And then we're going to see if we can factor that denominator to give it a different form. Because remember, each form tells us a piece of information. I think we can. I think this is going to be x minus 4 and x plus 1. All right, so let's deal with the things that we did in our steps first. First we always did was the vertical asymptote. In other words, where does the denominator equal 0 at? Well, our denominator equals 0 where x minus 4 times x plus 1 equals 0. Meaning that x equals 4 and x equals negative 1. And so that's what we're going to say for our vertical asymptotes. X equals 4 and x equals negative 1. So we got that. All right, the horizontal asymptote. Well, when we would assess this thing, right, we'd take our highest power from our numerator, which is x in this case, and the highest power from our denominator, which again back to original form tells us is x squared, and then we assess. Denominator beats numerator, so it tells us that our horizontal asymptote is at 0. So in this case, we're going to say y equals 0. We say y because it is a horizontal line for this, and we want to make sure we're writing it in good terms here. So y equals 0 is the horizontal asymptote here. So no slant asymptote, but a y equals 0. All right. Then let's come back here and talk about the x and the y intercepts because that's how we did the steps, right? Our step number 1 was vertical asymptotes. Our step number 2 was horizontal asymptotes, and then we did the y-intercept and the x-intercept. So let's deal with the y-intercept next. So on the y-intercepts, where x equals 0, and if x equals 0, back to the original form, we're going to have negative 1 in the numerator, and we're going to have negative 4 in the denominator. So it looks like a positive 1/4 is that. So again, we want to write that as 0 1/4. All right, so that's one of our intercepts here, 0 1/4. Write that down. All right, the next is the x-intercepts. And for the x-intercept, for a rational, it is we want to have y equals 0, but really it's where the numerator equals 0 at. And so where does x minus 1 equal 0? When x equals 1. And so that's our point. It's going to be 1, 0. I'm going to put that up here as well, 1, 0. Now we would also do the Achilles point check, step number 5 in ours. And by having a horizontal asymptote of 0 and having an x-intercept on there essentially gives us that Achilles point. So this 1, 0 is on the Achilles point. It is the Achilles point. All right, before we can answer D and E, let's go ahead and graph the function. Then we can come back and talk about the domain and the range here. Get your Cartesian coordinate system laid in here and put down what you know. All right, I know that I have a intercept here is 0 and 1/4. So if I call this one 1, my 1/4 is probably about right there. And I have a 1, 0 as well. So here's 1, 0 right there. I also have vertical asymptotes here at 4 and at negative 1. So 2, 3, 4. Remember, that's a dashed or dotted line at 4. And then we have one at negative 1 as well. Remember how this graph works? That these vertical asymptotes separate the graph into 3 sections. You've got the section that is negative infinity to negative 1, the section that is negative 1 to 4, and the section that is 4 to positive infinity here. Okay, what we know for sure is in the middle section, because it goes through the horizontal asymptote, our graph is probably going to look like this. But then that goes what happens on the ends, right? Remember, it's either above or below the horizontal asymptote. So our graph is either going to be in this section on top of the where negative 1 and negative infinity come together, or on the bottom. Same with the side from 4 to positive infinity. It's either top or bottom. So to do that, we have to figure out test points here. So let's go ahead and test negative 2 and see what happens there. And then let's test positive 5 and see what happens there. If I put negative 2 into this form here, I get negative 2 minus 1. That tells me I have a negative in my numerator. Negative 2 minus 4, that's a negative. Negative 2 plus 1, that's a negative. A negative times a negative in my denominator is a positive. And so what I have in my total fraction is a negative divided by a positive, which is a negative. And since it's a negative, then I know my graph has to be down in this section right here. All right, for positive 5, 5 minus 1 is 4. That's a positive number in our numerator. 5 minus 4 is a positive there, and 5 plus 1 is a positive. So a positive times a positive is a positive in my denominator, and a positive divided by a positive down my fraction is a positive, meaning our graph is in this section. The only question we haven't answered yet is part D here, the domain and range. So our graph will help us answer that question. Looking at our x values here, it looks like we can have just about every x value with 2 minor exceptions. Obviously, we can't have anything here on the -1, and we can't have anything here on the 4. So our graph is going to have to be split into parts here. And what we're going to say a domain is it's going to be from -infinity to -1, and then from -1 to +4, and then from 4 to +infinity. Basically, it's a long and fancy way of saying it can't be -1 because there's a vertical asymptote there, and it can't be 4 because there's a vertical asymptote there. Now, range is up and down. And because we have a value here that goes through the horizontal asymptote, we have values everywhere. So our range value is actually everything. It's -infinity to +infinity. So that's how you want to do domain and range on 17, and that answers 17 as a complete question. Sometimes these graphing ones can look intimidating, but you know, the way we've done it, we've just graphed it, and all these other things have been steps along the way. So treat it the same way when you do this example and anything that's similar to this on the exam, if it shows up.